Okay. So now I'm just taking the snap of a thermodynamics. So just tell me why the thermodynamics second law is called a qualitative law, whereas the first law is say as a quantitative law.
So second law of thermodynamics is called a quantitative law because it gives the direction to a spontaneous process. Means it says that quality always degrades. Means if we have a source at, let us say, 1000 Kelvin, and we are taking energy from it, then the quality of this energy will be more than a source at 500 Kelvin. So this is a qualitative law, and the first law is a quantitative law because it only says that energy can never be destroyed. It is only means transport from one form of energy to another. So it only says about the quantity of the energy.
Okay. So second law will govern the which thing will produce by the second law of thermodynamics.
Produce in sense means
Which things governed by the just like a
which things are governed by the second law of thermodynamics.
Yeah.
Second law says about the entropy of the system surrounding and the universe, and it says that entropy always increases. Yes, sir.
Because can you tell me just if I'm just saying that all reversible adiabatic processes are called isentropic process, while vice versa is not a true. Why?
Okay, all reversible adiabatic processes
Called a asentropic process, but
yes,
but vice versa is not a true. Why?
Vice versa is not a true means all isentropic processes may not be reversible and adiabatic both at the same time. So means we have to see that the entropy is basically a function of external irreversibility and internal irreversibility. There is the entropy generation. So if let us say that means external irreversibility that is del Q by T, and we sum it to the entropy generation, DS generation. So let us say that del Q by T is positive of 5 units. Okay, and delta S generation is negative of 5 units. Then it will be an isentropic process, but it at the same time it is not an adiabatic process. So that is the inverse is not true.
What do you mean by COP?
COP is coefficient of performance. It's basically referring to the efficiency of the refrigerator or the heat pump.
Efficiency. You can just relate the coefficient of performance to the efficiency also.
Means it is means as in heat engine we are referring to efficiency, means we are getting output, means output as work done, and we are giving the input as heat input. And in the COP we are getting output as the means the output as this Q, means that is a refrigeration effect. So it is the output, and what input we are giving is the work. So in one sense, we can say it is the efficiency for a refrigeration cycle.
So you are just saying that both efficiency and the COP are the same thing.
No, not the same thing. Not the same thing. I'm referring that means we can means denote for a refrigeration cycle. This efficiency means how efficient a cycle is. Means how much less work I have to means give to the system, and how much more means refrigeration effect I can produce. So if COP will be more if the refrigeration effect will be more and more.
So COP can be possible less than 1 or not?
COP less than 1, yes. For refrigerators, it is possible. For heat pump, it is not possible.
So refrigerator it's possible. In which case it's possible?
In the case in which means let us say for heat pump we are saying na. For heat pump, if we take any cycle for heat pump, it is, let us say the COP is 1.5 or something. So for a refrigeration cycle, the efficiency, no, the COP of refrigeration cycle is COP of heat pump -1. So in that case, it can be less than 1 also.
I'm just asking in which case of COP is less than 1 possible. I'm not talking about the heat pump. Can it be possible in the case of a refrigerator also? Or any other things also?
Which case? Sorry, sir, I'm not able to think about that.
Okay. What do you mean by Kelvin-Planck statement?
Kelvin-Planck statement states that it is impossible to make a device or means create a device which works on a cycle, and at the same time it gives a work output, but it does not have to means send any heat to the sink. So it says that there is no engine which is possible which gives 100% efficiency. Means it takes heat and it means gives a 100% output of that heat. So it is not possible. The Kelvin statement states that.
Okay, I don't know about the Joule-Thomson coefficient.
Yes, sir. Joule Kelvin coefficient or Joule Thomson coefficient is basically the slope of the inversion uh, the slope of the TP curve.
Rahul Ranjan joined me at 12:25. Okay, Rahul, you can just leave now and join me at 12:25. Rahul, am I audible to you? Rahul, am I audible to you? Please leave now and join me at 12:25. 12:25 पे ज्वाइन करिए आप.
Yes, sir.
ठीक. Okay.
So the Joule Thomson coefficient is basically the slope of the TP curve, which is formed when some gas is means expanded or throttled. So by that way means by that mu, that is the Joule Thomson coefficient, we can see that what the temperature will be after throttling. Means it will decrease or increase. If the Joule Thomson coefficient is positive, then it will increase. If it is negative, then it will decrease.
So are you know about the value of a Joule-Thomson coefficient is less than 1 or greater than 1 in which reason?
In which?
Reason, cooling reason or heating reason?
The Joule Thomson coefficient will be positive in the cooling region and it will be negative in the heating region.
Why?
It is so because means I have to show the curve for that.
Okay, just show. Just draw this.
Okay. So are you able to see this?
Yeah, I can.
So as we know that after the throttling, the pressure always decreases. So pressure will always decrease. So in that case, the inversion curve goes from here. So at the inversion curve, exactly at the inversion curve, the slope of this enthalpy line will be 0. So if the means Joule Thomson coefficient is positive, that the slope is positive, then the temperature should increase. You can see this. The means this decrease the temperature should increase. Sorry, not increase, decrease. I'm sorry. If the means it is in the cooling region, so it will decrease. Temperature to decrease.
Okay, just can you give me an answer that I'm just taking an example of a football. A
Yes,
football is going to be punctured in a playground.
Okay, sir.
Okay. So what will happen? Its temperature जो coming out air है उसका temperature increase करेगा, decrease करेगा, constant रहेगा और कोई effect नहीं पड़ेगा.
Okay. The football is punctured, air in it. So we can assume it as a pre-expansion process. So for a pre-expansion process, the air is coming out. But we cannot take it as a free expansion process because the means the surrounding is not vacuum, so it will create resistance to it. So if we take unsteady flow process, we take it as a control volume. So the temperature of the gas which is coming out, उसका temperature बताना है. Okay. Sir, sorry, sir, I'm not able to think right now.
Okay. Next question. If a air is heated from a 0 degree centigrade to the 100 degree centigrade in a sealed container, what's the effect on the density?
Okay, it is a sealed container heated from 0 to
To the 100 degree centigrade,
it is a
density
sealed
में क्या effect
container.
आएगा?
The volume is same.
Mhm.
So the volume is the V remains same, na? So density will remain same. The specific volume remains same. Mass is not added from anywhere, and the container volume is remaining same. The density will be remaining same. How will the density change if the specific volume is not changing? Means in a container we have a amount of mass which we are not changing. So mass is not changing, and the volume is not also not changing.
But
So
temperature is going to be change something.
yeah, temperature is going to change, but according to the means ideal gas law also, PV equals to MRT. As the temperature will change, means temperature जितना change होगा उतना ही pressure change हो जाएगा. So this basically it will be equated. So volume and mass remain same, then yes, density will remain same.
So what do you mean by PMM2?
Perpetual motion machine of second kind, because perpetual motion machine, this perpetual motion machine violates the Kelvin Planck statement. It says that an engine is possible which gives us 100% efficiency. Means we don't have to reject any heat in the sink. So whatever we give, let us say we give 100 kilojoule of heat input, then work will be produced 100 kilojoules. This is PMM2.
Okay. So कौन सा क्वेश्चन पूछ रहा था मैं?
सर आप PMM2 पूछ रहे थे.
Okay, so you just give it a Kelvin Planck statement, है ना?
Yes, sir.
Okay, no issue, no issue. So Ghanshyam, today I'm just taking give you the 15 minutes only, है ना? Next time we will discuss some more questions also on that, है ना? अभी मंडे ट्यूसडे वेडनेसडे मैं लीव पर हूँ, सो आप ज्वाइन मत करिएगा, है ना? अगर मुझसे करना है तो दोनों दिन ऑफ रहेगा मेरा. इफ यू वांट टू ज्वाइन देन यू कैन ज्वाइन ऑन थर्सडे फ्राइडे सैटरडे एनी डे, है ना? और उसके बाद 2 हफ्ते तक मेरा कोई लीव नहीं है, सो यू कैन जस्ट ज्वाइन मी इन एनी टाइम.
Okay, sir. No issues. Sir, today's interview, can you give the feedback?
Just about the feedback, everything is good. As such, no issue. Sometimes I'm just try to involve some practical questions also, है ना? क्योंकि मुझे पता है कि आप लोगों का जिनका भी गेट का रैंक अच्छा है, आई नो वेरी वेल अबाउट दैट. ही इज मोर गुड इन डेफिनेशंस आल्सो. आप सबकी सब डेफिनेशंस में अच्छे हो. इतना मैं अभी डेली वॉक लेता हूँ तो मैं देखता हूँ जनरली किसी से भी अगर कोई भी स्टेटमेंट पूछा जाए तो सब लोग मेडी से पढ़े हुए, सब कहीं ना कहीं से कोचिंग लिए हुए, तो सबको स्टेटमेंट्स वगैरह सब बहुत अच्छे से याद है.
Yes, sir.
So we are just going to some more practical question. In case someone asking you some research type questions or something like that, so you can just enhance your knowledge. Like, आप सोच सको वहाँ पे.
Yes, sir.
बाकी अच्छा है, आपका कोई इशू नहीं.
Okay.
Thank you.
sir.